November 2016. A massive steel arch has moved slowly over the site of the worst nuclear disaster of all times. This is Chernobyl, the site of 4 of the former Soviet Union's nuclear power plants, located on the Ukraine-Belarus border. On the 26th of April 1986, an explosion at one of the plant's 4 reactors sent radioactive debris into the atmosphere and contaminated most of Europe. The hastily built concrete and steel sarcophagus has survived till now. With a massive financial investment from the European Bank of Development and Reconstruction over the last 20 years, the international community has worked with post-Soviet Ukraine to deliver the largest ever mobile structure, a massive arch that has been slid over the sarcophagus in order that the aging radioactive carcass can now be safely dismantled and disposed of.
May I have your attention, please? A fire emergency has been reported in the building. While this is being verified, please leave the building by the nearest exit.
1:28 a.m. on the 26th of April 1986. Chernobyl. Scientists are doing tests at the nuclear power station with 4 reactors, one of the technological jewels of the Soviet Union. They want to see if the turbine can provide enough backup power during a blackout to keep the cooling water flowing while generators kick in. A sequence of errors leads to a buildup of steam in the reactor cooling water. There are 2 explosions that literally blow the top off the reactor into the night sky. Over the next few days, radioactive material shoots into the atmosphere. It not only falls on the surrounding countryside, but is carried by the winds as far as Finland and Italy. Soviet soldiers and pilots volunteer heroically to stem the radioactive fallout and then to build an enormous steel and concrete structure over it. The whole area is evacuated as the plant continues to unleash 200 times more radioactivity than the Hiroshima and Nagasaki atomic bombs. It is the most catastrophic nuclear accident ever, a disaster that will kill hundreds and create permanent ghost towns across a wide swathe of eastern Ukraine. Today, the protective structure built to contain the radioactive material, known by its Soviet-era name as the object shelter, or more commonly as the sarcophagus, lies under a massive steel arch, hermetically sealed and built to allow work on the steel and concrete structure that still houses the radioactive fuel rods that were the core of Reactor 4 at the Chernobyl power station. The explosion in 1986 released just 3% of the radioactive material of Chernobyl into the atmosphere. The remaining 97% lies beneath the deteriorating concrete shell of the sarcophagus. It is one of the world's most dangerous ticking time bombs. The new containment structure is designed to reduce the risk of another future disaster.
The whole program that we are financing there, the so-called Shelter Implementation Plan, includes much more than only the construction of the new covering. There were quite a few preparation measures and infrastructure that wasn't present here and had to be financed. And the whole program costs a little over €2 billion.
Since Roman times, and even before, everyone knows that the arch is an extremely effective structure in terms of weight distribution.
The nature organizes cooling of the core of the reactor. It was maybe complicated to explain, but in reality, From day to day, the temperature of the core decreased.
The massive arch that now covers the old sarcophagus is the result of decades of planning and designing, not only in conceptualizing a new containment structure, but also in lifting it and moving it over the decaying concrete monster. Building it directly over the sarcophagus presented a significant health hazard for workers. So the largest ever man-made object to be moved over land had to be built at a safe distance from the old structure and then had to be slid into place. It was a mega move of a massive half-dome and an amazing piece of engineering. Balthasar Lindauer is overseeing the final phase of the huge job that the European Bank of Reconstruction and Development has undertaken over the last 20 years. The construction of the arch, the destruction of the old sarcophagus, and removal of the radioactive material.
The new covering by itself cost around 1.5 billion euro, of which the design effort surely is the smaller part, even though it requires a lot of people to work on that. But the more expensive part is the construction. And for that, the 1.5 billion euro were mainly costs. We are then ready. As I mentioned before, the EBRD is ready with the project. After, it will be handed over to Ukraine after completion of all works.
The massive engineering effort that over the last 20 years has gone into building the arch of Chernobyl, known as the new containment structure, was possible because the sarcophagus built over the radioactive reactor held up for so long. Nikolai Steinberg was in charge of the project from the week after the disaster.
We start preliminary works in May. We cover the site around unit number 4 and unit number 3 by concrete up to 3 meters. By the end of May, maybe. It was made decision by top management of the Soviet Union that Ministry of Middle Machine Building was appointed as responsible for design and construction of sarcophagus. In '86, we spent 5 months for construction, design and construction. An absolutely incredible situation.
Today, the structure that Nikolai Steinberg hurriedly threw up under mounting international pressure and under the watchful, worried gaze of the whole world is being dismantled and replaced by a new, safer steel building soon to be handed over to the Ukrainian government.
Here it's about a step-by-step approach. The state of knowledge about the reactor and the shelter that was built wasn't that good. So the first step was to actually develop a detailed plan how to approach this problem. Surely we are dealing with a destroyed reactor. A majority of the radioactive material is still in the reactor, and around it we had relatively high radiation exposures.
The high gamma-ray radiation levels close to the reactor dissipate with distance from the radioactive core. This led to fundamental consequences for the project.
That makes this operation much more complicated and more expensive than other construction sites. And an important factor was that we decided, and this was an important design step to say, we built the concealment aside from the reactor and then pushed it over. The main purpose of this was to reduce the radioactive pollution for the workforce.
In 2007, the first pieces of this immense steel construction began arriving from Italy. They had been built based on French designs produced by powerful computer programs. Once on site, the pieces had to fit perfectly. Everything had been calculated to the millimetre. Even the lifting processes that eventually moved the arch over the steel and concrete sarcophagus of doom. On the 25th of April 1986, tests on the backup power system require a lowering of the power produced by reactor number 4 of the Chernobyl power plant. But a request for more electricity from Kiev delays the experiment, and an inexperienced night shift team first remove and then reinsert control rods that reduce the uranium rod reaction, provoking first an uncontrolled drop and then a rapid rise in the reaction, and causing a massive head of steam to build up in the cooling water that, at 1:28 a.m. on the 26th of April 1986, eventually blows off the top of the reactor core.
So the problem was connected to thermohydraulics and physics of the reactor. Some mistakes of personnel, jointly with design mistakes, realized in explosion. For personnel, it was a situation when they should implement all their knowledge and moral condition to be in the real war.
The Soviet government evacuates 360,000 people over the course of the next month, leaving small towns like Pripyat completely empty. Ghost towns frozen in time. Eerie snapshots of life interrupted by the worst nuclear disaster the world has ever seen.
For first 6, 7, 8 months, in reality in Soviet Union was created the system of Chernobyl issue management absolutely adequate to situation in the war.
46,000 people used to live here, shop here, go to the theatre here, and enjoy their days off in the fun fair. Before the disaster, 1,000 babies were born here every year. Pripyat, like dozens of others in the 100-kilometer-wide exclusion zone, is just a ghostly reminder of the cities that once were. Now being overtaken by forest, flora and fauna that instead have survived against all odds. As the disaster unfolds, more than 600,000 pilots, soldiers and civilians, known as liquidators, begin stemming the flow of radioactive material, sacrificing themselves to drop hundreds of tons of cement onto the reactor from helicopters and building steel and cement structures around it to contain the dust. Hundreds die of radiation sickness. The heroes of Chernobyl are commemorated outside the Chernobyl fire station and in the Chernobyl Museum in Kiev.
Main priority was safety, how to decrease level of occupational exposure, decontamination of the site, restoration of the unit, because we have very strong task for us to return unit number 1 and 2 in operation by the middle of autumn. So it was our responsibility. In May, my task was decrease as much as possible number of people at the site.
12 years after the disaster, the political situation of the Ukraine changed dramatically after the fall of the Soviet Union. the highly contaminated site of the Chernobyl disaster, and 2 other reactors that still pumped power to the rest of Ukraine, were identified as new priorities in the development program for Eastern Europe.
Es ist natürlich eine große Herausforderung für einen Staat, der zu dem Zeitpunkt.
It is, of course, a big challenge for a state that, at that time, was newly founded and that had economic difficulties to be confronted with such a unique and grave problem like Chernobyl. We also felt that during the implementation of the project, it was a huge challenge in many respects, regarding the training of the people that are needed here. Also for all possible financial support that is necessary for everything around the project to make sure that Ukraine can master this challenge. With time, we built a very good team, and we are pleased with the collaboration with Ukraine.
Wir sind hochzufrieden mit der Zusammenarbeit mit der Ukraine.
The European Bank for Reconstruction and Development stepped in, with 45 donor states. But there were many key details that had to be fully explored before the project could be set in place. The company that won the contract to actually build it was a consortium between 2 French engineering companies, Vinci and Bouygues. They formed Novarca, the company that built the arch, and today manages the final phases of the project. Cyril Fagier is the project director for Novarca.
Welcome in the Arch of Chernobyl.
The general dimensions, 108 meters high, 260 meters wide, between these plinths and the ones to the south, and then 160 meters in that direction, as we cover the whole object shelter, the reactor, and the whole thing weighs more than 36,000 tons. When we skidded it, it weighed 36,000 tons, and in the meantime we've continued to add equipment and tools, so now it weighs a little more. But that's the general idea, nearly 40,000 tons.
The arch is big enough to contain the whole of Notre Dame Cathedral in Paris. Over the 10 years of construction, the new confinement structure transformed an ambitious engineering project into the world's largest land-based movable object. It had to be built where workers would be safe from radiation, at least 150 meters from the radioactive core.
Quand les équipes de Vinci et Bouygues sont arrivées donc en 2007, ils ont trouvé un terrain.
When the teams from Vinci and Bouygues arrived here in 2007, they found a contaminated terrain with radioactive objects. So the first stage was to clean, first of all for worker safety, and then to build a platform on which we could work. We even built a thick concrete platform to stop all the radiation coming up from the Earth from reaching the surface, and that allowed us to work in a completely safe environment.
De remonter, donc ça a permis de travailler dans un environnement qui était absolument sûr.
The land is slightly sloped, so designers had to take the local landscape into consideration to give the arch perfect vertical stability. The plan also involved skidding the arch into place, using skid shoes set at 45 degrees to the surface to take the full load of the arch. These tracks had to be designed into the project too. The available area to build the concrete foundations of the construction yard was not large enough to house the whole of the arch, so the French engineers came up with a novel solution.
Rather than build a concrete platform that was the size of the whole arch, which would have been enormous, especially taking into account the contamination of the Earth, we decided to build the arch in 2 pieces. A first semi-arch was built, and this was moved, and then we could take full advantage of the special foundations, and also the famous lifting towers that were already in the right place, to build the second half. The second half arch. These 2 half arches were then brought together. They were connected. Here we did have some welding, but it was planned, and it's the only place where we had to use welding in the whole of the construction.
The arch that today stands over the Soviet-era object shelter, or sarcophagus, is designed to survive for at least 100 years. Even though the half-life of the radioactive material will make the site dangerous long after that. The designers took into consideration the potential threats from climate change, over-budgeting for extreme weather. It had to survive Force 3 tornadoes and temperatures as low as minus 40 degrees centigrade. The arch shape makes the structure solid, with the entire weight of the steel and concrete resting on the plinths on the concrete floor specially built to house it.
La première chose, c'est qu'on a décidé de construire l'arche.
The first thing we decided was to build the arch several hundred meters away from the reactor. Why? Obviously, because the further we are away, the lower is the radioactivity. So we had to work far enough away to allow us to work in normal conditions, so as not to have limits on the length of our working hours.
The arch not only had to cover the entire old sarcophagus, but it also had to allow workers to dismantle it remotely, without being exposed to the toxic dust and rays that the reactor emits. To do this, the planners decided to install 2 remotely controlled cranes that could lift toxic material and have different tools attached to them. This, of course, would increase the required resistance of the arch itself. Once the overall principles had been established, it was up to the individual engineers to come up with a robust design structure that would do the job. The sustaining element of the new containment structure had to hold up the inner and outer surfaces, plus the 2 gantry cranes. The French engineers came up with a trellis structure made up of tubular steel elements that used intersecting pressures to offload the weight onto the foundations, very similar to the world-famous steel trellis Eiffel Tower in Paris.
La structure de l'arche, en réalité, elle est constituée d'une structure primaire, c'est vraiment la structure porteuse.
The arch structure is actually made up of a primary structure that carries the weight and through which all the forces are channeled. This is a trellis with a distance between the upper chord and the lower chord of 12 meters. This constitutes the annular space, and you'll see it later. Then we covered the primary structure with a secondary structure with curlings that allow us to position the cladding, the stainless steel skin, which is a little more complex than it seems, as it is really a multi-layer surface.
Qui est un peu plus complexe que ça, parce qu'en fait c'est un multicouche.
The heavy lift company that Novaka brought in to move the arch they had designed was Mamert. The company had become famous for raising the Kursk submarine, using massive strand jacks, a tool that would play a key role in this massive move too.
En réalité, quand les équipes de Vinci et Bouygues ont conçu cette arche,
In actual fact, when the Vinci and Bouygues teams designed this arch, they designed it together with the people who would work on the construction site and with the subcontractors that have the expertise. All the details are designed with the tools we'll be using in mind. We can't design such a concept and then wonder how we're going to actually build it on site. It has to be done as a partnership and hand in hand. And it worked very well.
Ça doit être fait vraiment en partenariat et main dans la main, et ça a très bien fonctionné.
The tubular steel structures were built in Italy by oil platform specialist Cimolai. They were designed to fit each other with incredible precision, with flanges and pre-tensioned bolts holding them together.
Obviously, this whole structure was designed on a computer, which is traditional now. But we also built computer models, because we had to be absolutely certain that as we were putting together these thousands of pieces in the construction yard, they would slip into place, and each hole match up with the facing holes to the millimetre. So the assembly was carried out virtually in the design bureau in Italy, and that allowed us to build the structure in record time.
Et ça a permis de monter ces structures en un temps record.
Parts for the lifting towers were delivered too. These were designed to be built on a skidding system that allowed them to move outwards from the arch's centre line. They had a vital role in the overall plan.
Tout a été fait par boulonnage. C'est la technique de boulon précontraint.
Everything is held together by bolts. The technique uses pre-tensioned bolts. So the bolt is pre-pressurized and compresses the two plates, so the forces are exercised through friction. A funny detail is that there are 700,000 bolts in this arch. 700,000 pre-tension bolts have been used to hold this arch together, and this works extremely well.
Once the central part of the arch was finished, the covering panels had to be lifted onto it by cranes. Keeping control of them in the high winds was an extra challenge, and they were large enough to catch the wind and fly like wings. The outer panels were built first, to give protection to workers as they built the inner surfaces. They were made of stainless steel. The inside and outside surfaces were different. The inner surface was beveled so as to reflect the gamma rays internally, and the outer surface was as smooth as possible to keep the rain and snow off it.
There's an inside and an outside. The skin is stainless steel, but the outer surface also has layers of watertight material and isolation, which makes the sandwich slightly more technical.
None of the movement would have been possible without the intervention of vertical lift by strand jacks and horizontal slide by skid shoes, technologies mastered by Mahmut. The key to building the arch in segments was being able to lift the semi-arches, and this could only be done by lifting towers.
So
the construction method was a real challenge. How do you build a structure that is more than 100 meters tall, 260 meters wide, without using gigantic tools or cranes? So the teams, the design teams and the construction teams, that's what we call the constructability study, decided first to build the central part, the upper part, the part that today is 100 meters high, to build it on the ground. Why on the ground? Because it's easier. We need small cranes. It's safer. In safety terms, it's better to work close to the ground rather than at very great heights.
The segments had to be lifted and moved. The engineering solution was complex and daring.
Then we would lift this central element using the lifting towers, and then with this element suspended, build the elements on either side, the elements of the arch on either side, then lift again, and then build the last elements of the arch that allowed us to rest the arch on these plinths.
The key element in lifting such a heavy weight are strand jacks. These are hydraulic lifting devices that spread the weight among many separate steel strands and then apply hydraulic force to lift the weight. Steel teeth bite into the strands and hold them as the hydraulic pumps fill once more to begin a new lift. They are slow but powerful. Especially, they have to work in perfect sync, all together, to get an even lift all over the surface.
Les tours ont été livrés un petit peu comme l'arche, évidemment, avec des membrures évidemment bien plus petites.
The towers were delivered like the arch itself, obviously with shorter beams, also held together by bolts. So the lifting technique that was chosen was the strand jack, installed by our subcontractor Mahmut, each of which allowed us to lift weights up to 15,000 tons. We invented a new method, so we designed a system by which we could skid or move these towers from one position to the next. There were 3 different positions.
D'une position à l'autre, effectivement, il y avait trois positions différentes.
The months went by, and the first segment was ready to be lifted. But first, the gantry cranes had to be installed. Then came the day for the first mega lift. It was a slow operation, and controlling it was a challenge. Giant strand jacks mounted on 10 towers pulled for 12 hours to get the roof into place. While the middle segment of the arch was set in place and rested on the concrete foundations, as the towers were skidded outwards. Cables tensioned by strand jacks kept the edges of the arch from bending outwards as they were lifted, to ensure perfect fitting of successive segments as the top was lifted to its full height. The operation was repeated one last time, and the lower segments of the arch were built and lifted. But this time, they were positioned on the upper surface of the skid shoes that had been laid to transport the mega arch over the aging Chernobyl sarcophagus and the dangerous cargo encased below it. The first arch was moved towards its final resting place to make space for the second half that went through the very same process. In all weather, winter and summer alike, the workers of Novarka and Mamut worked together to move the project forwards. In all, up to 3,000 workers were on site at the height of activity. There were no accidents. It was literally a mammoth task. On the 22nd of November 2016, the arch was ready to be slid over the brittle and decaying remains of the sarcophagus. It was the make or break moment of the whole project. The arch was ready to be slid over the sarcophagus, the symbol of the worst nuclear disaster ever.
Der Auftrag für die EBRD ist die Errichtung dieses.
The task for the EBRD is the erection of complex systems that are in the confinement structure. For example, the ventilation system is extremely important, fire protection measures, the crane system that we need for that. Everything that makes this system what it is our responsibility. As soon as the confinement and the whole plant is fully finished, we will hand over everything to the Ukraine authorities that will use these systems later to remove radioactive waste and strip down the reactor itself over a long period of time.
Den Reaktor selber im Laufe der Zeit über große Zeiträume zurückzubauen.
The whole arch weighed 36,000 tons, and the intersecting beams meant that all the weight lay on the outer surface of a trench built at 45 degrees to the horizontal. The entire weight of the structure was held in place by skid shoes. Skid shoes are able to move the loads they carry by pushing against Teflon sleepers that they literally skid over. Each of the skid shoes moved at 10 meters per hour, slowly but surely, towards the sarcophagus. By the end of the seventh day, it was in place.
Donc, ce qui est remarquable ici, c'est en fait.
What we can see here is the structure of the plinths, and they're technologically relatively simple. We see these plinths holding up great works of art, and the whole of the arch's weight is offloaded here. And when I say weight, I'm talking about the arch's own weight, the weights from external factors, earthquakes, winds, and so forth, but also of equipment, because inside the arch, and you'll see it later, the main crane system, so we have two enormous gantry cranes that weigh 1,500 tons each, two monsters. It's very interesting. So the weight of the cranes and the weight of what they carry are spread through the structure of the arch and lie on these plinths.
Et puis des charges qu'ils portent redescendent également via la structure de l'arche sur ses appuis.
Now the skid shoes had to be removed, and the weight of the arch rested on huge plinths built into the diagonal wall of the foundations. Today, the 30-year-old sarcophagus is completely covered by the new structure. And while the surrounding countryside is eerily, deathly quiet, the site itself is a hive of activity. The gantry cranes are active all the time, as workers consolidate the building with a containment scaffolding and cover it so that eventually the radioactive core can be removed. This structure represents a 30-year effort to reduce the future risks posed by the worst nuclear disaster of all time.
The main task, main goals for construction of new safe confinement was to protect environmental from distribution of radiation from unit number 4. Unfortunately, study of this object, from my point of view, for the study spent so much time, so 20 years for study, design and construction. Once more, I would like to underline, in '86, we spent 5 months for construction, design and construction.
Today, the new containment structure covers the Chernobyl sarcophagus that still contains what is left of the reactor number 4 of the Chernobyl power station. The massive trellis of tubular steel arches can be seen from the stairs that lead to the upper gallery. Activity around the old concrete and steel building is intense. The Chernobyl Arch is also equipped with a state-of-the-art control room, where every environmental parameter can be monitored. A massive air purification system ensures that no radioactive material from the work going on inside ever gets out. Here, HEPA filters are activated at any time there is a rise in contamination. And as workers climb the 100 meters to get to the top of the building, where the gantry crane is operated, the skeleton of the arch becomes visible, with the thousands of bolts and high-tech steel beams. It is a confined world of its own.
Notre contrat, le contrat de Novarca, des sociétés Vinci et Bouygues.
The Novarca contract between the companies Vinci and Bouygues will cease when we hand over the keys and train the teams of Chernobyl power plant to use this tool. So it will be up to them, maybe through subcontractors, to begin the second stage, which is dismantling.
D'amorcer cette seconde phase qui est le démantèlement.
Now the new safe confinement, as it is called in English, has a lifespan of 100 years and allows then with time and planning to determine the next steps and to conduct these steps. A concept has to be developed. Which parts of the reactor have to be removed? Which radioactive materials shall be extracted from the reactor? A lot of other questions also have to be solved, and that, for example, where the material is to go after it is being extracted from the reactor. Since we developed a safe system with a lifespan of 100 years, these things can be approached calmly.
En réalité, cette arche, elle est conçue pour durer 100 ans. Donc, on parle...
In actual fact, this arch has been designed to last 100 years, so we studied earthquakes going back several thousands of years to be absolutely sure that in 100 years it would suffer no damage. And of course the big challenge when we say 100 years is the durability of the steel, because we selected stainless steel, and of course the final user asked us to limit the amount of maintenance they had to do. So we have a structure that over the next 100 years won't need painting.
Et donc on a une structure qui pendant 100 ans n'a pas besoin d'être maintenue, elle n'a pas besoin d'être peinte.
It's a nuclear object, and all people which work at the site should be absolutely ready for any situation and prevent such situations. That's all. It's a nuclear site.
Eventually, all the radioactive material from Chernobyl will be removed to a safe place, a second project to be financed by the European Bank of Reconstruction and Development. Chernobyl's radioactive risks may be laid to rest for now, but the ghosts of Pripyat will haunt Europe forever.
From my point of view, no one other government in the world could decide this problem. It's a reality. In such time, very short time, no one. It's my opinion.
The air, water and soil will always be monitored, even as tourists of the macabre brave all kinds of weather to visit what was once a thriving small town, a proud symbol of successful Soviet society, that overnight became one of the most grim and catastrophic landmarks in all of humanity. Despite the reminders everywhere of how normal life was once here, this place may never return to normal, doomed to exist under the dark cloud of environmental uncertainty forever.